Howdy, welcome back to Stagehand Learning. This is Fiber Basics. This module will cover the basic structure of a fiber cable as well as some common connectors used in entertainment and proper handling. Feel free to pause the video at any point to look at diagrams further or to read extra information. The part that makes fiber so useful is the core, a microscopic thread of ultra-pure silica glass. This fiber is 9/1000ths of a millimeter. That's less than 1/10 of the finest dog's hair. The core is surrounded by cladding, a layer of varying material types, but all of them of a lower refractive index to keep the signal contained and flowing. The core and the cladding are then protected by various layers of different materials to help reduce the chances of damage, depending on the type of cable and its intended purpose. Some of the most common damage to fiber is micro and macro bending. These are usually caused by choosing a poor cable path and thus allowing the cable to get pinched, crushed, or pulled. Damage like this causes the signal to go in unintended directions and all of the information doesn't get to its final destination. Because the signal is transmitted through glass, it is very important to keep the ends clean. The easiest way to do that is to put the caps back on after every use. LC and ST are some of the most common connectors used on patch cables and fiber snakes. LC has a little tab you push down on, just like an RJ45 on an Ethernet cable, and ST has a half-turn collar like the B and C connector on an SDI cable. Other common connectors are Opticon and HMA. There are several different brands with quad connector fibers out there, but for lighting and video and live entertainment, we primarily use OpticalCon or Opticon by Neutrix, whereas audio often uses a 4-channel beam connector called HMA. These are cool because they're hermaphroditic and you can't run them backwards. It's really common to see these types of connectors when running fiber reels, which are generally 500 to 1,000 feet. These are the built-in connectors on the equipment. Notice the caps tethered to it. Like all fiber, it's important to keep the connectors clean and covered. Tactical fiber snakes are 2 to 24 individual, usually single-mode fiber strands in one jacket that can have the same or different connectors on each end. These are usually 100 to 300 feet. These are commonly referred to as tack or strand, like tack 4, tack 12, or a 4-strand or 12-strand. Patch cables are generally less than 10 feet, but more commonly 3 feet or less. They come in simplex and duplex, or single and double, and again, they have the same or different connectors on each end. These have less protective materials in their outer jacket because they're typically inside of racks. SFPs are basically an adapter to convert fiber to a network or device usable connection. A lot of the larger switches have 2 to 6 SFP slots like the one below. This is an Aja Fido. It uses an SFP to convert fiber to SDI or vice versa. One of the most important things to check is that your SFPs are the same or they will not talk to each other. It's also important that they have the proper bandwidth for the equipment they're being used with. There is single mode and multi-mode fiber, but our industry primarily uses single mode. They both have benefits and drawbacks, so you just have to choose what's best for your project. These are a few of the articles I found helpful and borrowed some images from. They're of course geared towards telecommunications, but there is a lot of applicable information in there. Thanks for watching. Remember to hit that like and subscribe.